This video is all about Pythagorean triples. What you're going to be asked to do is you're going to be asked to look at the converse of the Pythagorean theorem and apply it. So here's an example of a problem where you're going to have to apply the converse of the Pythagorean theorem. The question is, do the side lengths 3, 4, and 5 form a right triangle? Is this set of numbers a Pythagorean triple? So the Pythagorean theorem backwards, the converse would be, if we find that a squared plus b squared equals c squared, then it must be a right triangle. When you say it forwards, like the normal Pythagorean theorem, we would just say, if you have a right triangle, then a squared plus b squared is equal to c squared. Put simply. So let's look at this example, 3, 4, and 5. You'll notice over here that I already did the work, and I wrote out the formula, I plugged in 3, 4, and 5. What you need to pay attention to is that when you're given 3 lengths, they might not always be given to you in order, and you have to make sure that the largest side goes in for the 5 when you're checking to see if it is a Pythagorean triple. 9 plus 16 gives you 25, and 25 equals 25. So we would say, since a squared plus b squared equals c squared, then a triangle with side lengths 3, 4, and 5 is a right triangle. So basically we proved that it is a right triangle because a squared plus b squared equals c squared. So we would call that a Pythagorean triple. It's the 3 lengths. Those 3 lengths are Pythagorean triple because those 3 lengths form a right triangle. Let's move on. Next example. Do the side lengths 13, 5, and 12 form a right triangle? Is this set of numbers a Pythagorean triple? Now, this one's a little bit more difficult. You have to pay attention to the fact that they listed the 13 first instead of last. And you have to notice that the 13 has to go in for C because C is the hypotenuse, and the hypotenuse is always the longest side of the triangle. When you plug it in, you're going to end up with 24 plus 144, which is 169, which is going to equal 13 squared. These two are equal, so you do have a Pythagorean triple, you do have a right triangle. Example 3. Do the side lengths 6, 24, and 30 form a right triangle? Is this set of numbers a Pythagorean triple? I feel like this is what they like to do to trip you up on the EOG. They like to give you numbers that are going to add up to get, the largest number. But remember, the Pythagorean theorem is a squared plus b squared equals c squared. It's not a plus b equals c. So you'll notice in the work that it's not going to work. So if you take 6 squared and then 24 squared, you're going to get 612. If you take 30 squared, you're going to get 900. And 612 is not equal to 900. So the numbers 6, 24, and 30 do not form a right triangle, and it's not a Pythagorean triple. So here's the longer version of that work. But again, those are not equal, so it's not a right triangle. And I just thought it would be good for you guys to become familiar with some Pythagorean triples. There's some common ones that are used a lot. Let me close this so I can scroll downwards. So a 3, 4, and 5 is used a lot. 5, 12, and 13, 8, 15, 17, 7, 24, and 25. Those are ones that I see over and over again. Let me zoom out a little bit so you can see them all. And of course there's more than that, but that's, a good set of them. So all you're going to do is, if you're given 3 lengths, you're going to plug it into the Pythagorean theorem, making sure that the longest side is put in for C. And then if it's equal, it's a Pythagorean triple, you have a right triangle. If both sides are not equal, then you don't have a right triangle and you don't have a Pythagorean triple.